Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Rachel Thomas. This month we really enjoyed meeting some young female mathematicians who were just finishing up their summer research projects through the Philippa Fawcett Internship Programme and the Cambridge Mathematics Placement Programme. We were running writing and editing workshops with them, and it was so fascinating to hear about their research projects and their hopes for their careers and to help them develop their ideas for communicating their work, no matter which part of industry or academia they head into. Now, as you walked into the workshop on the wall in the Centre for Mathematical Sciences, you walked past 6 inspiring portraits of female mathematicians from the University of Cambridge. These portraits form part of the Women of Mathematics photo exhibition, which celebrates female mathematicians from institutions throughout Europe and was launched in Berlin in the summer of 2016. When Cambridge hosted the exhibition in 2017, when the Cambridge mathematicians contributed their portraits, my colleague Marianne Freiberger had the opportunity to interview these women about their work and their mathematical lives. In today's podcast, we revisit our 2017 interview with Nilanjana Datta, then a lecturer and now a professor in quantum information theory. She told us why she loves maths and about some of the challenges she's faced as a female mathematician.
Would you like to start by introducing yourself, please?
So I am Nilanjana Datta. I'm a university lecturer on quantum information theory here at the Department of Applied Maths and Theoretical Physics, and also a fellow of Pembroke College.
Okay, and could you tell us how and when did you choose to do mathematics?
Well, as far back as I can remember from my early school days, physics and mathematics were my 2 favorite subjects. I had 2 other passions. I also liked dance and creative writing. And I still remember when I completed the Indian equivalent of GCSE, my English teacher, who was a very enthusiastic Irish nun, was rather upset that I chose to do science after that. But once I reached, started 6th form, it was absolutely clear to me that mathematics and physics are the subjects I want to study.
Mm-hmm. And what's it like being a female mathematician in particular?
It is quite challenging because, as you very well know, we are a minority in this field. And surprisingly, to me at least as far as university students are concerned, we are more of a minority in the Western world than back home where I come from in India, where we were like half and half. And so numerous times, for example, even during my research, I have been asked by various people, why do you do mathematics? Why do you do physics? And the answer was clear, because I love the subjects. But I still remember when I expressed surprise that I was asked this question, I was told that, don't you know, mathematics is not feminine. So there are these prejudices one has to fight against. Often I've been mistaken as a secretary in the department. The challenge makes it all the more exciting.
And what advice would you give to a young woman who is thinking about doing mathematics?
Yes, I would have a word of advice for them. That is, if you like mathematics, then forget the prejudices. Ignore what others think. Just be passionate about it. And I have been asked many a time by young female students whether it's possible to have a life, a family, children as an academic doing mathematics. And I would say, yes, of course, it's completely possible. I have a family, I have a son. And I remember when my son was born, some of my older colleagues, male colleagues, told me, oh, surely you're going to quit mathematics now. But of course I didn't. Of course, you have less time, but that doesn't matter. We are women, we can multitask. And you have shorter time, but you can focus your thoughts and concentrate much better. And it's even more satisfying. So I would say that if this is what you want to do, then don't let anything stop you.
Good. And for you, what are the joys of doing mathematics and what are the challenges?
Joys of doing mathematics. A couple of things appeal to me really about mathematics. And one of them is that it's about pure reason. It's about absolute truth. So there is no room for compromise or vagueness or varying points of view. When you prove a theorem, then the statement of the theorem is a fact which nobody can refute, and that's wonderful. And another thing is the simplicity and elegance of maths. We know that using mathematics, one can explain very complicated and complexities of nature and matter through some beautiful, elegant, simple mathematical equations. And this is very appealing to me. And also, another fact is about doing mathematics, the simplicity of it. We don't need a laboratory, expensive equipment or anything of the sort. All we need is a paper and a pencil, and sometimes not even that. I mean, I remember many a time sitting at the dinner table with my family and secretly puzzling over some proof that I've been stuck at, and my husband saying, "You're not really with us, are you?" But this is the joy of maths. Yeah, it is. When you prove something, it's wonderful. It's it might be a very short-lived joy, because then you're stuck at the next step, but it's still something I would not give up for anything else.
And could you explain your area of mathematics to somebody who doesn't know anything about maths?
Oh yes, I could try. So the field I work on is called quantum information theory. So information theory by itself, which is often called classical information theory, is the mathematical theory of storage, processing, and transmission of information. And the importance and relevance of this in our daily lives is obvious to everyone. Yeah? All of us spend considerable amount of time every day acquiring information, sending messages, processing information, and there are more and more platforms or methods to do it using emails and texts and social media, laptops and mobile phones, etc. So what I work on is quantum information theory. So what's the quantum bit? So that's the theory of these information processing tasks when you use quantum mechanical particles like electrons and photons and atoms as information carriers. So as you know, quantum mechanics is the fundamental theory of microscopic particles, particles on a subatomic level where it replaces Newtonian atomic or subatomic level where it replaces Newtonian mechanics. And so because of this underlying quantum mechanics governing the dynamics of these information carriers, one often gets totally new effects, and which are not there in classical information theory. And these new features can be exploited to perform certain information processing tasks much more efficiently, much more quickly, or in an improved manner compared to classical information theory. So that's my field of research. It's a highly interdisciplinary field. You'll find pure and applied mathematicians, physicists and engineers working on this field. It's very exciting, though my research is more focused on the mathematical aspects of it.
Okay. And could you describe one of your favorite mathematical moments?
Oh, yes. Well, I remember one day. So I was invited to an international conference called TQC, which was held in Tokyo in Japan. Unfortunately, the time of the conference was during Cambridge term time, and I was lecturing a course. So I did something really crazy. I went all the way there just for 3 days, and that was the stupidest thing to do. So I reached there totally jet-lagged, completely exhausted, stressed about my talk. And then I remember attending one talk by a Japanese scientist, and suddenly, just at the end of the talk, the haze seemed to have cleared. I went out for my coffee break, and I had one idea, just one little idea. And strangely enough, that little idea has now become my main field of research. And in fact, we now have an annual conference which is based on this small field, and my introduction to that field was through that little eureka moment way back in Japan, all those years back.
That's amazing. Okay, thank you very much.
Okay, thank you very much too.
That was Nilanjana Datta talking to my colleague Marianne Freiberger in 2017. You can see the Cambridge posters from the Women of Mathematics exhibition and find out more about their work and their mathematical lives at plus.maths.org/content/women. And stay tuned to this podcast for the rest of the interviews with these brilliant women of mathematics coming over the next few weeks. The music in this podcast is from the band Yusa, and the track is called Plankton. Thanks for listening, and bye-bye for now.